Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap. I'm really excited about this one, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either one of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. So at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. Also during today's web presentation, we are going to be doing a polling question. So please, hopefully we can get everybody as involved as possible. All right, with that, we'll go ahead and kick off today's webinar, which is Born for DevOps CI/CD, Accelerating the Transformation to Mature Software Manufacturing. Our speakers today are Darwin Sanoy, who is Senior Solutions Architect at GitLab, and James Bland, who is Partner Solutions Architect DevOps at AWS. Welcome, gentlemen. Thank you so much for joining me today.
Thank you, Charlene.
Great. So, James, I know you're going to be kicking us off, and I know it's a great presentation, so I'm going to put myself on mute and let you get right to it.
All right, thank you. So as we get started, I wanted to level set on the definition of DevOps. The term itself was coined around 2009 and has morphed into all sorts of things to describe a culture, people, process, methodology, tools, and even an engineering role. I don't think any definition is wrong as long as it brings people together to try and solve a common goal of increasing an organization's ability to deliver applications, features, functionality, and services at a faster pace to meet and exceed their customers' demand. On the last slide, I talked about the definition of DevOps, but there seems to be a new term in town that's modernization. If you recall, the term DevOps was coined around circa 2009. Architectures, patterns, tools, and cultures looked very different at that time. So the industry needed a new term that didn't feel like we were locked in a time capsule. So modernization is really DevOps, but reflects the lessons that we've learned and the adaptations we've made to meet the increasing demand of customers. A modern approach to software development is centered around several things. First, shrinking the scope by leveraging different techniques to prove or disprove hypotheses quickly in a fast and safe way in search of customer value. Second, offloading the undifferentiated pieces by seeking out ways to do less in order to do more. Third, choosing the right tool for the job to create more purpose-built solutions and less effort. And fourth, automating everything for speed, consistency, and safety. Customers are building modern applications by changing their people, process, and technology so they can innovate faster and more frequently and bring those innovations to market faster, all while reducing costs and building more reliable applications. In the next few slides, I have lessons learned from Amazon and other organizations I've worked with that will help you unlock the full potential of the AWS cloud. But before we get started, I wanted to remind everyone that modernization is a journey and not the final destination. The best practices I'm about to present is what has worked for Amazon, and it is what we have learned in our own journey. One of the early things that Amazon realized was that to unlock the full potential of people and communications, that they needed to restructure into 2 pizza teams. These teams were long running, would own a specific set of functionality, and the teams were responsible for both developing and operating the services. They use the you build it, you run it mentality. And I can tell you, when developers now are on the hook for answering late night pages, their mindset shifts, and then they start thinking about writing high quality software that is resilient and self-healing. I can tell you from experience, after being woken up 1 or 2 times, I put all my effort into getting better sleep. For Amazon, this change was rooted in the idea of figuring out what is most important to your business, your North Star. by thinking about where you want to be in 3 to 5 years. At Amazon, we knew time to market was our North Star, and so we made a people decision, and then we made some technology decisions to support this. When you're working with a monolithic app, you have many developers all pushing changes through a shared release pipeline, which causes friction at many points of the lifecycle. Up front, during development, engineers need to coordinate their changes to make sure they're not making changes that will break someone else's code. If you want to upgrade a shared library to take advantage of a new feature, you need to convince everyone else to upgrade at the same time. Good luck with that. And if you want to quickly push an important fix for your feature, you need to merge it in with everyone else's in the process. This leads to merge Fridays or even yet merge weeks, where all the developers have to compile their changes and resolve any conflicts for the next release. Even after development, you also face overhead when you're pushing the changes through the delivery pipeline. You need to rebuild the entire app, run all the test suites to make sure there are no regressions, and redeploy the entire app. To give you an idea of this overhead, Amazon had a central team whose sole job it was to deploy the monolithic app into production. Even when you're just making one line change in a tiny piece of code you own, you still need to go through the heavyweight process and wait to catch the next train leaving the station. For a fast growth company trying to integrate, innovate, and compete, this overhead and sluggishness isn't acceptable. Microservices are minimal function services that are deployed separately but can interact together to achieve a broader use case. When monoliths become too big to scale efficiently, we take a couple of big changes. One was architectural and the other was organizational. The teams were decoupled and they had the tools necessary to efficiently release on their own. Teams independently architect, develop, deploy, and maintain each microservice. Ownership is key. Every team service has an owner. Owners architect, owners implement, owners support in production, owners can fix things, and owners care. Each microservice often has its own data store, and each microservice is fully decentralized. No ESBs, no single database, no top-down anything. Any given instance of a microservice is stateless. State, config, and data pushed externally. Microservices support polyglot. Each microservice team is free to pick the best technology. DevOps principles, automated setup, and developers owning production support. Use of cloud for elasticity, platform, and software services. So how do we communicate now that we are distributed into microservices? Sharing data stores across microservices introduce coupling, which we don't want because it creates synonymous communications with the sender waits for the response. This creates dependencies between the microservices, which in turn creates performance and availability problems. Instead, we aim for all data exchange between microservices has to be through an API layer or messaging. Messaging can really help us achieve scalability, fault tolerance, high availability, consistency, and distributed transaction management by providing a mechanism for reliable durability, fault tolerance delivery of messages, creating unidirectional, non-blocking operations, decreasing the dependencies they have on each other, enabling focus on logical decomposition of systems, and increasing autonomy of our components. You probably want messaging services to do this. What does this mean for software you buy from key suppliers and vendors? You want to seek vendors that embrace APIs. We build a lot of software at AWS. Our services consist of a lot of source code, but even the installation and upgrade routines are managed at code themselves. We use APIs to deploy and manage our software whenever possible and drive our service teams very hard to build, then leverage APIs whenever changes are needed or when you need information from the runtime environment. How can you effectively automate if the installation requires command line access, typically very privileged access, or relies on a graphical interface where you click next, 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 finish? Well, you can't. As use of the cloud has dramatically increased, the industry has seen a lot of vendors integrate and the APIs of cloud providers hosting those solutions. It's important that these solutions have their own APIs so you can continue to automate not only the resources offered by the underlying cloud provider, but also programmatically get at the data from the solution itself. To take full advantage of elasticity of the cloud, you want to treat everything as code, not just the application, but also the infrastructure and the configuration. Really, it's about how to eliminate manual errors, reduce surface area for things. When we traditionally think of source code, we think of apps, websites, business logic, back-end services, transactions, etc. But now everything is like source code: firewalls, routes, load balancers, identity permissions, monitoring alerts, all of it. In the cloud, all of these resources can be expressed in what is essentially code. Well, to us humans, it's configuration. But as we move through the pipeline, our software and APIs of the cloud platform will turn that configuration into a running resource that performs the same functions as things we traditionally buy and put in racks. By treating your infrastructure as code, you immediately remove the humans from the entire control plane of the network, storage and compute, provisioning and management. You no longer make changes to live running assets. You change them in source control and let the pipeline test and deploy the updates. Using infrastructure as code allows you to lower the cost by redirecting resources to more important business needs. Improve consistency by reducing human error, which can lead to deviations from configuration standards. Agility by increasing the speed at which your organization can release new versions of services in response to customer needs and market drivers. Improving your ability to attain and maintain compliance to corporate or industry standards due to the absence of repeatable processes. We believe in putting this abstraction in at every part of the application. Customers are trying to make an application that serves a purpose. Customers tell us, I want something completely automated, an easy button. They are asking us to remove their operational load the same way we did for storage, the same way we did for compute or databases, and they want it done at a cost model that makes sense for each workload. AWS is abstracting away the infrastructure for people who don't want to deal with it. Serverless is really a state of mind. It is the relentless drive to eliminate all things where you don't add value. It's about adding value where it is needed, the business. Another best practice I want to talk about around modernization is to leverage event-driven architectures. In the simplest terms, an event is a signal that a system state has changed. In most modern systems, these are represented as JSON messages that provide some set of facts about what changed and potentially what the current state of the system is. One of the key distinguishing features of events compared to commands is that events are observable, not directed. In a command model, each command is explicitly issued to a specific recipient. Events, on the other hand, are merely observable by other systems. So here, a customer just ordered a widget. One of his coworkers is adding it to the sales report. Another decides to send an invoice, and several others aren't even listening at all. What's nice about this is that it means that the event producers don't need to have any knowledge about who is listening to those events. This keeps them simple and allows other services to consume events without needing the upstream system to change. The benefit of event-driven architectures is that it allows you to shrink the scope of work by breaking it up into smaller pieces. This allows us to distribute the work while decreasing waste so we can focus on value. By no longer having to coordinate all the listeners and manage all the downstream tasks, systems become simpler and more focused. Another important shift we made with our architecture is that there are no gatekeepers. There's no line to wait in for storage, compute, databases, or to start using machine learning. In the old world, when you asked engineering teams how long it would take to get a new server to try an experiment, you get answers like 10 to 12 weeks. We set out to reinvent the experience to increase the rate at which we could experiment. We thought others would benefit from this as well, and in 2006, AWS was born. Now in the cloud, you can provision thousands of servers within minutes with 165 services that you can put together and use in whatever combination you want. You get from an idea to implementation in several orders of magnitude faster. This totally changes an organization, increasing the amount of cycles employees spend thinking about innovation because they know if they have an idea, they have a chance to see if it works. This expands the group of people inside a company that are thinking about new ideas from a select few to everyone. In a traditional application, there is one release pipeline shared between many teams. This process often introduces bottlenecks, which is why we decomposed functional hierarchies at Amazon and gave teams more autonomy. When teams have the authority to move fast, they can release new features continuously, often several times per day. You can see from this design, teams are not encumbered by other teams to release. They release when they are ready and at a pace that aligns with their business objectives. This best practice is to have at least one pipeline per team, but that doesn't limit teams to only having one pipeline. Some teams have multiple pipelines to split application from infrastructure. The point being is that this is left up to the team to decide what works best for them and not some overarching organizational requirement. We can then provide security of the pipeline as well as security in the pipeline and things like artifact validation and static code analysis. We can provide built-in, constantly reinforcing guardrails that allow teams to move quickly while following the rules you define. When I hear guardrails, I think of highways. If you think about it, highways have defined speed limits, marked lanes, rules for passing, on-ramps and exits, and the curves in the road were designed for travel at higher speeds. With these rules, we're able to travel faster and move freely at any time of day, on and off the highway, as we see fit. Each car has autonomy in their movement and decision making, but think about how frustrating it would be to have toll booths when we're cruising along at 65 miles per hour and have to then slow down, stop, and wait in a line to pay. Gates have a similar but often more disruptive effect on our software development process and flow. Modern applications have automated guardrails in place, allowing for the removal of gates, resulting in increased speed, autonomy, and agility. More than a decade ago, Amazon took our monolithic code base and broke it apart into service-oriented architecture. We refactored our single code base into smaller, focused, single-purpose services, which we call primitives. For example, we have a primitive for displaying the buy button on a product page, and we had one for calculating taxes. Every primitive was packaged as a standalone web service and had an HTTP interface. The business logic and critically the data were only exposed to other teams through hardened APIs. These building blocks only communicated to each other through the web service interfaces so that other teams could take advantage of existing services. This created a highly decoupled architecture where these services could be literally on independently as long as they adhered to their web service interface. To give you an idea of the scope of these small services, I've included this graphic on the right. This is the constellation of services that delivered the Amazon.com website back in 2009. And today there are tens of thousands of these across Amazon. Today at Amazon.com, we have over 190 million deployments a year. When we talk about two pizza teams, cultures, microservices, APIs, and teams with their own pipelines, remember that it has a practical application in the business. So at this time, I want to turn things over to Darwin at GitLab, who is going to talk about DevOps CI/CD. But before we do so, I have a quick poll question I'm hoping everyone can help answer.
Yeah, so we'll go ahead and push out this poll so everybody can take part. Should be showing up on your screen now. The polling question is, how would you rate your current level of continuous integration maturity? Your selections are just getting started. Around half of our builds are through CI, completely automated on CI and working on QA and other stages, or we have this down pat, everything is automated. So go ahead and make your selections. We'll give you guys a couple seconds more before we close it out and take a look at the results. Also want to remind the audience real quick that we are taking questions from the audience. So we will be having a Q&A at the end of the webinar. So if you have a question at any time, you don't have to wait. Just go ahead and use your GoToWebinar control panel and submit your question. Okay, I think at this point we can go ahead and close out the poll here and take a look at the results. Looks like the majority of folks have about half of their builds done through CI. So how does this jive with what you guys are hearing or seeing out there?
Thanks a lot for answering the poll, everyone. I'm going to just show my screen here. So my name is Darwin, and I'm a Senior Solutions Architect from GitLab. I thought I'd repeat that since my name was on the title slide, but I have not spoken to you yet. I want to take you through a little bit of a journey with regard to software manufacturing. So it looks like 41% of you say you're just getting started with CI/CD. So I think a lot of these concepts will really connect with you. What we want to do is fashion. Sometimes the timeline for it will be picked without too much regard for this certain things that really can't go any faster than a certain limit, sort of like terminal velocity if you're familiar with skydiving. Well then, oops, sorry, hit the wrong key here. Looks like I cycled around. 1 second. We'll then talk about the Russian nesting doll effect. So there are some challenges that we can have when working with automation, and that once we get done one part, we think we're all done, and we discover there's another layer very similar to what we had tried to do in the previous layer. So we'll take a look at that. We also want to talk about avoiding the DevSecOps Russian nesting doll. So DevSecOps can be a repeating pattern that at GitLab we feel is unnecessary with modern CI/CD technology. We also will then talk about how to have a tortured software manufacturing transformation. So basically talking you through some of the anti-pattern attitudes and ideas that frequently happen when people are approaching this transformation. And then finally, we'll talk a little bit about GitLab and AWS and how they work better together. So most folks are familiar with Henry Ford, starting with the manufacturing of automobiles. When we look back, of course, he provided automobiles to a lot of people. But when we look back, we see that we really feel that the key transitions that he did had to do with the automation of manufacturing, even though it started with the automobile. And one of the things that was key there was focusing craftsmanship on innovations that delight customers, rather than having craftsmen building every instance of the automobile. And so this key innovation allowed a lot more people to enjoy products cheaper with higher quality. And basically it comes down to whenever you have craftsmanship, you want to focus that on things that delight customers, and everywhere else you want to engineer things and automate them. And so let's take a look at how this looks both at Henry Ford's time and talk to you a little bit about some of the analogous situations we go through with software. So one of the things that this helps with is speed of innovations to market, being able to get those critical and new features and interesting things out to your customers more quickly, improving predictability and quality, lowering the cost of production and maintenance. There is a surge investment to get automated, but once you're over that, you take advantage of some reduced costs. And then encoding of tacit human knowledge into intellectual property. Tacit human knowledge is those kind of things that someone may know how to do, but not know how to explain how they do. If you think of a chef making a souffle, they can make this beautiful dish that you might like to eat, but they have a harder time really boiling it down into simple steps that you can follow and get the same results. And then the removal of drudgery, when done with empathy, removing the kind of work out of the craftsmanship area that can be automated is usually the kind of work that people don't look forward to when they go to work. So this kind of removal of drudgery is a great aspect of it as well. So some of these elements we're going to look at are transitioning from the practice of software craftsmanship to the practice of software manufacturing. So early on in car manufacturing, things were more of a craftsman model, which means a very knowledgeable individual who knows how to build cars and also knows how to create new cars actually assembles each car. So craftsmen work on getting everything assembled and putting it together. There can be some specialization, so it's kind of a worst case scenario to have one person building an entire car. But still, there's a lot of involvement of the people who know how to make new things or build things, actually doing the day-to-day production of those things. This can lead to some challenges. There can be the skilling of workers can be challenging because each worker has to be a completely self-contained unit, knowing everything there is to know about the process. Scaling production can be difficult because of scaling up the workers. Consistent quality can be challenging. If you look at the pictures here, there's some small variations based on people's skill or experience or their past working with the product. Serviceability of the product. So the final product in a craftsman age, each product is custom fit. When you go back far enough, each screw was actually hand filed. So if you had to fix that particular piece of equipment, you had to hand file another screw to fit exactly in the hole. And so the serviceability of the product is another important part. And then that transformation of tacit knowledge into a corporate asset. So one of the essential challenges is that integration of know-how and manufacturing labor into one individual in the case of crafting. Now, if you want to think about the software industry, this would be the stage of the software industry where everyone is doing builds on their individual workstation. So they have to know everything there is to know to build that software. Sometimes their machine is challenged to complete the task, or it may even take hours to complete the task. That particular machine has to be built very well. Sometimes it's handcrafted over the course of 6 months, and if it has to be replaced, that individual takes a really long time to become productive again as they get their working environment configured again. So software as craft kind of comes down to individuals working in their own little environment on their own machine, and everything is kind of siloed around what they know and how they know how to get it done. So the first automation maturity wave that happened was really getting the product into engineered plans that a product engineer could specify, and then having automation applied. And in that, we get over some of those challenges and limitations created by the old craftsmanship model. This craftsmanship transformation has some limits, and sometimes we don't always watch out for those. So when we go from crafting to engineering and automation, there are some various transformations that must take place. We already talked a little bit about the knowledge, the tacit versus explicit knowledge, but there's also individual knowledge versus shared knowledge. So being able to share the information about how things are built and how to assemble them. We also have implicit processes that an individual may be better at, and they don't necessarily share, not because they're selfish, but just because they don't think to. It's not required by their process into explicit processes. Another important one is product designed for craft assembly versus product redesigned for automated assembly. I've been in situations where configuration is littered throughout the entire code. I was on a transformational DevOps team, and we had to explain why we couldn't get the build automated, but there was a ton of application configuration right inside the code, and that was very hard to automate. So when we think about the 12-factor app model that you can look up online, this is an idea of creating products that are ready for automated assembly and deployment. And then integrated manufacturing labor becoming externalized and automated. We have a couple speed limits that hit us when we start to try to do this transformation. And one of those is the maximum bandwidth of deep know-how extraction. So even when people are willing and ready to get their knowledge out and into automation or into documentation, sometimes we go through documentation and then into code. There's a certain speed limit in getting all that information out, because you think you've told everything and then you find out, oh, that's right, we've got a couple more things. And this is a natural and normal process that has some challenges. Also, the maximum bandwidth of reskilling. So getting individuals who have been working in a craftsmanship model to work in an engineering model. Occasionally people ask, well, hey, what about if we just rehire instead of reskill? And it's important to realize that the folks who work in your company don't just know how to operate the code language that you're working with. They probably know a lot about the industry that you're servicing with your software and a lot of business rules in that industry. And that's hard information and takes a long time to get into new staff. In addition, there is not just the knowledge of the particular languages you're using, but the actual code base that you're using. So the reskilling is definitely a worthy investment, but it does take some time. We then also have product refactoring for assembly line production. And sometimes this is overlooked because people think that, well, hey, it's just code, just automate how it works. But if code is not built correctly, then we can have a lot of challenges trying to get it all ready for automated build. So I want to talk a little bit about something I call the Russian nesting doll effect. It's really a form of iteration, but it's kind of unpacking the same thing again and again. So when we start with product craft, we boil that down into engineering and automation. Once we get that completed, though, we realize that there's more inside. So inside that first factory that Ford built, there is going to be a bunch of people operating the individual machines or carrying parts around from station to station. It's not quite as automated as today's factories that we see on that first instantiation. So we have to then unpack that and kind of reduce this also to automation. So we get to that next level of maturity where that individual working is reduced to automation. We end up finding out that, guess what, there's some more craftsmanship going on, and that's actually the factory craft. So building and maintaining the factory. The first factories were not made out of standardized parts. They were manufactured specifically for that purpose. And so we want to get to a point where really we have assembly lines that are manufactured or built up from standard componentry wherever possible. And so this Russian nesting doll effect can keep going on. Another one that usually hits people is infrastructure as code. So once they reduce this all and they have applications flowing out and they're like, wow, we're CI/CD, and someone says, hey, we need a new test environment. And that same question that James was talking about comes up, and they're like, how long will it take to set that up? Oh, about 4 weeks. Why does it take 4 weeks? Well, we don't have that automated yet. So the idea here is that this continues to repeat. There's one area in which this continues to repeat that at GitLab we feel is somewhat unnecessary, and that's DevSecOps. So in DevSecOps, we still see a lot of going down the path of implementing individual tools, linking them together with maybe manual processes or manual communication mechanisms, having those individual tools attended to by all of the developers. And then we also, that automation can end up being fragile. We also have some late discoveries when we don't plan our maturity journey ahead of time. So we run into things we didn't think about at the beginning. So consumption-based scanning license models where every time you do a scan costs you some money. So all of a sudden, if you scan everything all the time, which is kind of the nirvana, you realize that that's going to be cost prohibitive. Tool implementation and training costs, and then the cost of not really having everything completely automated, including the process automation between security talking with developers. So these are things that GitLab aims to solve. We have a approach within GitLab that allows security to just take advantage of the fact that DevOps has automated CI/CD, and we've been able to reduce that to the single solution that is GitLab today. Customers have responded very well to that. They don't want to keep standing up individual tools to do their DevOps automation. So DevSecOps, just inheriting that benefit is a great way to start out with DevSecOps. This is even more true if you're a small organization. For those of you who are aware, there's many countries that never did put in telephone physical wiring, but as soon as cell phones became available, they were the fastest to adopt because they could completely skip putting in a physical telephone network. And this is kind of similar. We want to kind of completely skip some of those painful, slow maturation models. So let's talk a little bit about how GitLab helps accelerate this. We're going to unbox what I call the GitLab factory making kit. So GitLab is a software factory, but actually it's a factory making kit. So if you think of each of the assembly lines that you're going to assemble your software with, we can actually use Kit for that. So one of the prefabricated assembly lines we have is called AutoDevOps. And if your project is a well-expressed project in one of the top frameworks like Node.js, then this particular capability is able to recognize your code, recognize your unit tests, run all of that, do a build, do about 6 or 7 security scanning stages, deploy it into Kubernetes, and then also have production live threat monitoring in the Kubernetes cluster. That also supports Nginx, and we're also supporting ECS as well. So this prefabricated assembly line is a way for engineers, CI engineers, to become very quickly productive if it fits your needs. If it doesn't fit your needs, then the parts and pieces of these assembly lines can also be used and hooked into your own assembly line. So you just need SAS scanning, great, just include this bit of code. You just need something else, we'll attach another piece of code. Just need deployment, use that piece. In addition, we have more and more partners are prefabricating subassemblies to attach you into their scanners or into their frameworks or into their systems so that you can make GitLab's capability of having the developer builds integrated with third-party tooling. Also, something that's not well known is within your teams, if you have an enablement team that helps your developers get up to speed, they can build some of these subassemblies and share them. We have special capabilities so that you can, at your instance level or your group level, share entire project templates, as well as share GitLab CI templates. And you can accomplish exactly what we've done. In fact, the prefabricated assembly lines are completely built in GitLab CI, and that includes AutoDevOps, which is very elaborate. So the GitLab CI language is so capable that we can actually build chunks of product with that sub piece, and it's all completely open. You can go in and look at it and see how to build your own assemblies and your own assembly lines. Finally, I do get questions in meetings. Hey, I need to do a couple of things that we normally do in Jenkins or whatever other CI. Can you do that? Because it all looks like, we just got a whole bunch of prefab pieces. And GitLab also, you can drop to the ground and code from the ground up. So anything you can do in a CLI or in any build system or in any build system that's container-based, we have all of that. So we can help you with that as well. The key secret here to getting rid of Russian dolls is to start at the top here and work your way down. So figure out if AutoDevOps can work for the given project that you're working with. If that can't work, can you at least reuse some of the stages that are a part of that composable DevOps componentry? If that doesn't work, maybe there's some partners stuff you can use, or you can start to have an enablement team or an enablement person learn GitLab and start providing templated functionality for your developers. And then as everyone learns your GitLab CI language, they're able to build whatever they need to from the ground up. There's lots of ways to get involved with GitLab. We have both self-managed and SaaS. So you can host your own server, or you can get on gitlab.com and host your code there. There are 3 paid enterprise tiers, and we also have trials. So you can do a self-run trial or a sales-assisted trial of our gold features. In addition, there is free enterprise if you make your group public with your source open source, or I mean public. It doesn't have to be technically open source. And that allows you to have free CI minutes, gold features. If you're an OSS project, you are educational or startup, you can get the enterprise features for free as well and in a private format if that's what's needed. And then we have a community edition which has only open source code in it for organizations that have a very strong open source disposition and don't want any of our non-open source code in their solution. And then, so basically just kind of summarizing this bit, your production grade CI/CD automation should have a lot of the characteristics that we talked about. Prefabrication of bits and pieces is great. Scalability, GitLab is highly scalable, born for DevOps. High availability, it should be modular and be able to allow you to share bits and pieces. It should really focus on pipeline as code, which gives your engineers full control over the pipelines that they build. You should have 100% CI/CD automation whenever you're tackling your software manufacturing, and it should enable building your own CI/CD primitives whenever you need to. So let's talk a little bit about how not to do some of this stuff, how to have a tortured software manufacturing transformation. First of all, not accounting for both coding domains, so application coding and infrastructure coding. So setting up those environments at some point, if you're going to scale the number of environments you have, you're going to have to make an investment here. Not skipping the DevSecOps Russian doll. So going ahead and going through all the maturation processes that we've already done with DevOps in the DevSecOps realm. Not allocating surge time and resources for those culture, skill, and technical transformations we talked about that have some natural speed limits. So you either have to give more time if your current existing staff is going to simply grind away at both delivering features today as well as getting your infrastructure more automated, or you need to allocate some surge resources so they can be released and focused on that transformation. Not allocating time to refactor the product code itself. So there's a good chance if you haven't had automated manufacturing of your software, you're going to have to spend some time thinking about how to make those adaptations and discovering them through agile iterations. Not driving knowledge extraction, skilling, or product refactoring to done. So we find that folks leave, oh, you know, QA is still a little bit manual, or DevSecOps is still a little bit manual, and then they wonder why their actual throughput of development velocity doesn't really improve, but they haven't driven that knowledge extraction and the refactoring to done. Not automating all the Russian dolls, so is QA or AppSec still semi-manual? Not using off-the-shelf tooling whenever you can to skip some of these cycles of building it yourself. It's all too often you build something in CI and then a few days later you find out that, oh, GitLab does that built in just by running this one command or stage or GitLab CI YAML. It's also important to realize that craft is what creates all innovation. So the goal here is not to squeeze all craft out of building software. The goal is to squeeze the things that really aren't generating customer value so that you're not spending craftsmen or craftspeople time on that particular activity. So we're not spending a lot of time fussing with trying to keep builds working. We're spending time generating customer features that they really want to use. So that's kind of the lay of the land on software manufacturing. I want to talk a little bit about how we work together with AWS on multiple fronts in order to utilize the awesome and powerful application infrastructures that AWS has for you. What I've depicted on the screen is kind of the way that AWS approaches CI/CD, and the code pipeline in the blue is kind of your pipeline capability. And then you have a lot of ancillary services. As usual, in order to accomplish its scale, GitLab has a lot of ancillary services that are linked together in order to provide the capabilities that are there. GitLab deals with pipeline as code. So your pipeline is really defined by your GitLab CI YAML. And you actually have the developers, when they build out that pipeline, there's not really any infrastructure to provision or provide in order for those pipelines to process. Now, there's multiple ways to now integrate. There's one of the popular ways is to integrate directly with deployment. So if you use code deploy, I'll talk a little bit about in a minute about Amplify, Elastic Beanstalk, anything that has a deployment infrastructure implied in Amazon. You can integrate with those right at the end of your GitLab job and trigger those once you've done all your builds. GitLab does dynamic environments, review environments, which is not something we get into in depth in this conversation, but every time a developer commits a commit, it can update a dynamic version of your code running on Nginx or in a container and do DAST scanning. So you immediately know when they've introduced, or they immediately know when they've introduced a vulnerability. And this very dynamic capability is part of the GitLab CI pipeline. So we can integrate at the end here. We can also integrate with the common triggers for code pipeline itself. So S3, you can drop artifacts into S3 or into ECR, containers into ECR, and trigger a code pipeline. Now, this final one is one that confuses people, because if you're using GitLab and if you're using Amazon and you set up code pipeline, if you're trying to connect it directly to source code management, there's an option for code commit and an option for GitHub, and I think maybe Bitbucket now. So a question that we get a lot is, well, hey, I can't connect anything up to GitLab. So, you know, that's kind of a problem for me. And one of the things that GitLab has that introduces some flexibility here is repository mirroring. So you can set up GitLab to say, hey, push into that code commit repository. And this is very quick. As soon as someone makes a commit on the GitLab side, it can push up there within a minute or two. There's also some ways to optimize that. And we've actually recently added this to our documentation. So if you Google GitLab repository mirroring, you'll find that there's a section in there on exactly how to set this up. So if you do have to get into the very beginning of the code pipeline, you can indeed do that. We can also directly integrate through the Amazon CLI environments into any of the other application infrastructures that have their own specific deployment type capabilities built within that service. So I'm going to jump next to a slide that kind of demonstrates, you know, why bother with putting GitLab in the front. GitLab is got the concept of GitOps being integrated into it more and more deeply every day. And what this means is that deployment is handled by Git and its controls and by merges and by various operations of source code management. And in that regard, because GitLab has embraced GitOps early, a lot of our control mechanisms have become more mature because we need to control not just code build and verification and artifact generation, but also deployment into environments. And so these gating controls you have in GitLab are quite rich, allow you to do a lot of things with different people reviewing code, run a lot of CI checks, including all of our security scanning. And there's a lot of capability in there to really make that environment rich. And to do those review environments that allow you to do that constant security scanning as developers are developing their code each and every day before they even merge to a shared branch of any type. So all of this kind of capability comes along with GitLab when you implement it along with Amazon, no matter how you choose to integrate Amazon in the end. Just a couple of resources. So that documentation I mentioned is here on the screen. You can go back in the video to grab this when the video is published. And then there's also a video that backs up the one slide there called Rich Change Controls for Building Workflows You Can Trust. It goes a lot deeper into the various workflow controls, and that big slide I put up actually gets unpacked slowly in that video, like you've seen some of the slides in this presentation. With that, I just wanted to say that I work as a solutions architect at GitLab. So if you're wondering how GitLab can help you out with your CI/CD journey and try to make that a little smoother, help you with that transformation and iterative process and getting to full automation, you can contact our sales department and they can see about connecting you up with a solutions architect. I also have James and my social connections on the screen if you want to connect with us socially. Thanks, everyone. And I think we are going to hit some questions now.
All right, great. We've gotten a couple questions in so far, but there's plenty of time. If you have a question for either James or Darwin, please go ahead and use your GoToWebinar control panel. Let's go ahead and dive right on into the questions that we have. First question, how are separation of duties compliance handled in quote unquote, you build it, you run it?
I'll take this one. It's actually a very good question. So a lot of times the way that AWS is handling that is basically so you have segregation at different points. One is you have peer reviews when you're actually developing the code. But then also, if you remember, I talked about guardrails and also microservices. So each team is usually organized around, like the 2 pizza teams. And their guardrail is they're basically providing, let's say, security team, is they're providing an API to do security scanning on your code. So as a development team, you would integrate with their API so you can have your code scanned as it's going through the CI/CD pipeline. And you'd also use that same methodology with other teams. So if you're working with let's say, your QA team and you want to, they want to do builds and tests, then you would actually integrate that within your CI/CD pipeline, and that becomes basically the guardrails. And those guardrails are then what speaks to those segregation of duties.
I would just like to answer from the GitLab perspective as well. As I was mentioning about GitOps, some of the ways that we do segregation of duties are merges to branches, and you have the ability to have a lot of control defining different groups that have to be allowed to do certain merges, and that would target an environment. But in the more elaborate environments, we have some customers that will have their software and they'll have customers who are tenants of that software. And those customers might even have multiple environments. So the customer has a test environment, a production environment, and then they have 100 customers. And what we start doing there is we break it out into separate repositories. And you can either do merge requests between repositories or have one repository create the software artifacts and the second repository pick those up and push them. And then you can have a completely different set of permissions on the other repositories. You can even do, if you have the same software go to commercial and federal, you can have it so that the federal team has complete control over the repository that deploys to federal, and the commercial team does a forward merge request, and they can have complete control on that side of what happens at that point.
Excellent. Okay. Next question here. Currently, we are using AWS code pipeline in my production. I need one solution for that. How to roll back and how to deploy specific tag into the cluster?
I think that's for you, James, as far as pushing versions into clusters.
Yeah, is that is it a code pipeline question, or is that a more specifically a like a can this feature or functionality be replicated within GitLab?
Yeah,
So if it's Kubernetes, I can speak to the GitLab side for Kubernetes. So for Kubernetes, rollbacks are always just a redeploy of the previous version. So you can push a version tag into a cluster. Given Kubernetes, GitLab does not care where that is. It can be EKS, it can be your own cluster, it can be whatever you want. But GitLab would, from a GitOps perspective, even if it wasn't Kubernetes, it would handle it by redeploying a previous version. Also, some of the Amazon like code deploy has built-in capability to redeploy an old version right within that service, so it can handle it internally without going back to the beginning of a pipeline.
excellent. Okay. All right, great. Next question here. What GitLab scanning technology is available with GitLab DevSecOps?
Yeah, so GitLab has a variety of scanners that come with it out of the box, and I'll just drop a quick demo on here. I think I'm still showing my screen. So within the SAS scanning, you can see the toolkits that we use in order to scan code. You can go through all the other scanners over here on the left, so we can find out what is used for dependency scanning. You can find out all the toolkitting that's used. In addition, it's very configurable. So if we go down here to configuration, you can see how to add it to your pipeline. But also there, in the case of SAS, there's some 30 or 40 variables that you can configure. So that's your next level of being able to configure. But you can also, as long as you can get your security tool to output this format, you can plug in your own tooling. And this is how third parties plug their tooling in for security. So you can add scanners and plug them in, or you can even replace the scanners that GitLab ships with.
Excellent. All right, great. We have time for maybe 2 or 3 more questions here. How do we create our own GitLab CI prefabricated bits?
So GitLab has basically you create some GitLab CI, and within GitLab itself, you can use a container or not, depending on how isolated you want to be. But down here, I'll just quickly show you. This is an example of a standalone bit of GitLab YAML. It has a little trick here of putting this dot in front of the name of the job, makes it kind of like a reusable function that doesn't run when it's encountered. And then the other trick is just making sure you use variables for any data coming in or out of this bit of code. And then when we call this code, we can call it, this is an example of calling it. So we say, hey, it's over in this project. It happens to be in the same project in this case, but it could be in a different one. This is the file name. And we can also peg a version by using git refs. So if you tagged it or you use a branch, you can say exactly what version of this particular plugin code you want to use. And then right here, we're extending that little function that was in the other file. And then we add on this information in order to give it its parameters so it will process correctly. Now, interestingly, because we can reference something that's in a completely different project, you could have a set of shared code or plugin extensions that are under different version control from maybe a central team than what the developers are using their own code. So when they reference this code, it's kind of like shared componentry that you're providing. This is basically how Auto DevOps works as well. Auto DevOps will typically implement containers as well so that the runtime environment is also completely assured and version pegged.
All right, great, great. Next question, I think this is going to be our last question here. How can, this is a good one, how can we encourage developers to automate absolutely everything?
Yes, so one of the ways is something called the do nothing script. This is one thing that I've come across on the internet, very good idea, but basically you write a script that just tells the human what to do. And interestingly, humans don't like to be told what to do by a computer. So after a while, they are like, you know what? I don't really want it to tell me to do that activity, because if I did 4 lines of code, I would be able to automate it. So this do nothing script is an interesting and very practical way to do that. Another practical way is doing DevSecOps checklists. So basically, if you have procedures that are not code yet, you need to turn them into human code or human executed code, which is basically a checklist. But the process of doing this really emphasizes and helps you document what's not yet automated. Also, the level of detail that people have to create when they execute a checklist again and again and they keep it updated. The amount of information they have to extract is very good data for actually doing automation, because you end up over time understanding, oh, there's an exception case on this step. If XYZ is true, then do this instead. And so as you boil this down into checklists, it can be much easier. Interestingly, Markdown supports checklists. So in GitLab, we have issue templates and merge request templates. And when you put Markdown checkboxes in there and check them, there's an audit log, and it also will tell you how many checkboxes are checked off out of how many total there are when you're looking at summary views of issues. So if you actually use Markdown checkboxes, you can start creating those checklists right in GitLab. And then you, through issue templates, you say new issue template, I want a deploy to production template, save that issue, and now you have a great checklist to just start going through. So the concept of coding, that into human code is really good, because, if developers don't want to automate, it's really hard for them to argue against having a really good process for releases that will make sure that they're done well and that they don't have to get up at night to help fix things up.
Okay, all right. Interesting stuff. Really, really fascinating. I love that do nothing. I do want to thank everybody who did submit questions. Unfortunately, this is all the time that we have for the question and answer period. If we didn't get to your question, please fear not. Both Darwin and James will be getting a copy of all of the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get your question answered. Also, want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go find it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, also real quick before we close things out, I do want to do the drawing for the 4 Amazon $25 Amazon gift cards. So without further ado, let's see, our winners today. Winner number 1 is Barry R. Congratulations, Barry. Our second winner today is Christopher W. Congratulations, Christopher. Our third winner today is Ernie B. Congratulations, Ernie. And our final winner today is Karen B. Congratulations, Karen. And all 4 of you, congratulations. We'll be following up with you via email to get your $25 Amazon gift card over to you. If you don't see it in your inbox, please check your spam folder. James and Darwin, thank you for a great presentation. Lots of interesting stuff. Really do appreciate your time and your expertise.
My pleasure.
Yeah, my pleasure.
Great.
Thank you.
All right. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. Please stay safe.